Assalamu alaikum. Hello everyone. I am Mr. Muhammad Sabri. We will talking today about Ohm's law and electric current. Okay, so let's start. To understand the meaning of electric current, we must studying the structure of atom. Okay, so we will talking now about structure of atom. We know that the atom consists of nucleus, the nucleus is considered as the center of atom, which contains two particles. The first one called by proton and has positive charge. Second particle called by neutron and have neutral charge. There are some electrons rotate around the nucleus in a specific orbit called by energy levels. These electrons has negative charge and rotate around the nucleus related to the attraction force from positive protons inside the nucleus and the negative electrons outside the nucleus. This means that all electrons rotate around the nucleus, rotate according to the attraction force from the positive nucleus. So, if the attraction force between the electron and the outermost energy level, the attraction force between the electron in the outermost energy levels and the nucleus vanished or weak, this means that the electron can leave the atom and become free electron. So if the electron leave the atom, we called it by free electron. So free electron, it is a small particles has negative charge, has negative electric charge. If this electron transfer from position into another position, this means that the electric charge transfer from this position into this position. So the electrons or free electrons inside metals or conductor responsible for transfer electric charge from position into another position. Okay, so if we have metal, this metal, most of atoms in the metal, all of them, the attraction force between of the electron in the outermost energy levels and the nucleus vanished or weak, we will have a huge numbers of free electrons which can transfer through metals and transfer energy, which is called by electric energy. Okay, so the metals contains a very huge number of free electrons which is responsible for transfer electric energy. Non-metals and bad conductor, which is called by insulator, it is the material which has no free electron which can't allow for electric current to pass through it. Okay, so now we will talking about the definition of electric current. Electric current called by, we can define electric current by, it is the flow of charges in a circuit which is called by current. Current means flow of charges in a circuit. I mean by charges, electrons which has negative charge and holes which has positive charge. Okay, this means that the flow of electric charge means two types of particles. The first one called by electron which has negative charge. Number two called by hole. Holes mean the empty space the electrons left behind it. Okay. Current I is measured in ampere, so means the measured unit of electric current intensity called by ampere and milliampere. So the symbol of ampere is capital A. Symbol of milliampere MA. Conventional current directional from positive to negative. There are two directions of electric current. Number one called by conventional current. Second one called by actual current or actual direction. Okay, so let's comparing between them. As the charge moves around the circuit from the positive to the negative, it loses energy. An electric current is the flow of negatively charged electrons. So the flow of negatively charged means by electrons, which flow away from the negative terminal of the supply or the battery around the circuit and back to the positive terminal. However, the traditional view of current flow from the positive to the negative. Okay? Traditional current also can be called by conventional. So traditional current direction means conventional current direction. This means that the electric current will flow from positive pole of the source towards to the negative pole of the source. Okay, this means the current will move from positive pole, passes by all electric parts in the circuit, then back again to the negative pole. We called it by traditional or conventional direction. The second direction of the electric current, we called it by actual or real. Actual, we can say real direction of electric current. Real directions mean the movement of electrons from negative pole towards to the positive pole. Again, we have two directions of electric current. The first one called by conventional direction. This means that the electric current moves from positive pole of the source to the negative pole of the source. Second direction called by actual or real direction, we can call it by electron flow direction. This means that the electrons flow from negative pole of the source towards to the positive pole of the source. Okay? Now we will talking about electric potential energy between two unlike charges. We have two types of potential energy. Number one called by higher potential energy. We give it by positive charge. We give it this symbol. Positive charge means that this area contains higher potential energy. Number two called by lower potential energy. We give its symbol negative. Okay, so if I have part of conductor, this has higher potential and this point has lower potential. So the electric current will move from positive towards to the negative. The electric current moves from the higher potential to the lower potential. Okay, so if the potential at right equal 5 volt and left equal 5 volt, okay, this means that the potential at right equal to the potential at left. Okay, at this case there is no move of electric charge from right to left or from left to right. There is no electric current passes from or between these 2 points. Okay, this means that to cause movement of a charge there must be a potential difference. This means that I must have area has higher potential and area has lower potential. The electric current will move from position has higher potential towards to the position has lower potential passed through an electric conductor. Okay, okay, we will back again to the parts of electric circuit. Number one, look at to the right picture. Okay, there are many symbols of an electric device. Number one called by battery. Battery is considered as source of energy. So battery is source of energy. Battery is the source of energy, not source of electrons. Okay. The role of battery inside the electric current is push electrons to move through electric circuit. Push the electron. It will push the electron to passes through electric circuit, then moves towards to the positive pole. Okay, so the battery, we can define it as a source of energy. Battery give electrons energy to pass through conductor and movement towards to the positive pole. Okay. Part number 2 called by switch. Switch, its importance in the circuit to open or close the circuit. Open the circuit, take this symbol. There are distance between these 2 points. This means that there is no electric current passes through circuit. Open switch means there is no electric current passes through the circuit. Okay. Close the switch, taking this shape. There are connection or conduction between these 2 terminals. Okay. This means I will conduct them. This means that the electric current will pass through the circuit. So we call this is by closed switch or closed circuit. Okay. Number 3, bulb, electric bulb or device. We can draw electric bulb as the symbol of resistance, taking this symbol. It's called by resistance. Resistance means any device can work by electricity. Any device inserted inside the electric circuit called by resistance. Okay. Look at to the picture on the left. The battery, okay, and lamp only. He drawing that 2 types of electric current. Number 1, electrons flow. Electrons flow from negative pole towards to the positive pole. We called it by actual direction. Okay, so let's complete. What happened when the switch is open? When the switch is open, there is no net movement of a charge across sectional of the wire. Okay, we said that there is no electric current passes through the circuit. What occurs in the wire when the circuit switch is closed? Look at to the right. This means that the electron moves from positive towards to the negative. The electric current moves from the positive, which called by area has higher potential, to the area which has lower potential. Okay, so if we close the switch, the electric current will pass from positive position to lower position. Closing the switch, establishing a potential difference, voltage and the electric field in the circuit. Okay, this means that the electrons flow in the net direction, away from the negative terminal. Okay, so the electron moves from the negative, passes through switch, then passes through 2 lamps and operate them, and finally reach to positive pole. Okay, so they complete the electric or closed electric circuit. They will pass from positive pole towards to the negative pole and complete the movement of current again. So the circuit still working. Okay, we said that the electric current is the flow of electric charge through a conductor. We can express the electric charge by physical quantity called by quantity of electricity. Okay, so we can express the value of electric charge passes through a conductor by quantity of electricity. It's simple Q capital. Okay, electric current intensity, its physical quantity. Okay, means the quantity of a charge that passes through a conductor through 1 second. Okay, Okay, so the electric current intensity, which that symbol is I, capital I, okay, equal quantity of electricity divided by time and measured by unit called by ampere. So the measuring unit of quantity of electricity called by coulomb and time in second. 1 coulomb divided by 1 second equivalent to 1 ampere. Okay, so the electric current intensity, its measuring unit called 1 ampere equivalent to 1 coulomb divided by 1 second and measured by using a device called by a meter. So the electric current flowing in a circuit can be measured by a meter. Okay, its symbol, this is a symbol of a meter. A meter connected in the circuit in the series connection. Okay, we connect a meter in the circuit at series connection. Okay, example, in 10 seconds 60 coulomb of charges flow around the circuit. Calculate the current through the circuit. In 2 seconds, this means that time equal 10 seconds. And the quantity of electricity Q capital equals 60 coulomb. Calculate the current through the circuit. So the electric current intensity equal Q over T. Q equals 60, time equal 10, so we will divide 60 divided by 10 equals 6 ampere. Okay? Question number 2. A current of 150 milliampere flows around the circuit for 3 minutes. How much the electric current flow, electric charge flow around the circuit in this time? Okay, so the given said that the electric current intensity I equal 3 milliampere. Okay, the electric current given by milliampere, so we must convert milliampere into ampere. We will do this by multiply by 10 power negative 3. So the electric current intensity equal 3 times 10 power 8 power negative 3 ampere. It's the electric current intensity. Okay, and time, we must convert time from minute into second. Okay, so time equal 3 times 60 equal 180 second. Okay, so the required is Q. Q equal I times T. So Q equal electric current intensity 150 milliampere, not 3 milliampere. يبقى equal 150 times a 10 power negative t times 10 power negative 3. Okay, so Q equal 0.15 times 180 equal 27 coulombs. Okay, it is the answer of the question. Okay, electrical energy. Okay, we will talking about the source of energy. The voltage between 2 points on the circuit is called by the potential difference between these 2 points. The potential difference between 2 points in the circuit is 1 volt if 1 joule of electrical energy is changed to other forms of energy when 1 coulomb passes from the 1 point to another point. Okay, I will explain it by another way. If I have a conductor, it's point A and point B. Point E has positive potential, has higher potential. Point B has lower potential. If we want to transfer quantity of electricity from point A to point B, this means that the energy or the battery will push the electron to move from A to B. Push of energy, push of electrons or push electrons through conductors means the battery must do work to transfer energy from E to B or transfer electrons from E to B. So as battery working, there are work done to transfer quantity of electricity of one coulomb from point E to point B through this direction. Okay? Again, the battery push electron to move from E to B. This push means there are work done to transfer quantity of electricity from E to B, which is called by potential difference. So we can define potential difference by using this relation. V equal work done in joule divided by quantity of electricity. So the potential difference can be defined by, it is the work done in joule to transfer quantity of electricity of one coulomb between 2 points. So it's called by potential difference between 2 points. Okay? So let's complete. Again, the voltage between 2 points on a circuit is called the potential difference between these 2 points. The potential difference between 2 points in the circuit is 1 volt. If 1 joule of electrical energy is changed to other forms of energy when one coulomb passes from the one point to another point. Okay? Measuring unit of the potential difference called by volt. The volt equivalent to 1 joule over 1 coulomb. Okay? So the potential difference measured in unit called by volt, which equivalent to 2 joule divided by coulomb. And we can use device called by voltmeter to measure the value of potential difference between 2 points. This device connected in parallel connection with the device. In the picture, this is voltmeter connected in parallel connection from point E to point B to measure the potential difference between E and B. Okay? The voltmeter measures the potential difference in the energy if the electricity between points E and B before and after it has passed through the bulb. Okay? As the electricity has a lot of energy, but at B most of this energy has been changed into heat and light in the bulb. Okay? Again, to explain this, the electric current moves from positive pole towards to the negative pole. This means that the electric current will pass through point A at the beginning, then passes through the electric bulb. The energy from the battery passes through the bulb. It converts into light energy and heat energy. Okay? Then the other electric energy from the source will pass to the point B. Okay? So the energy at A point is greater than the energy at B point. What's the reason of this? The reason of this, the energy from A moves through the bulb. This bulb consumed electric energy and converts it into heat energy and light energy. Okay? He said that as the electricity has a lot of energy, but at B most of this energy has been changed into heat and light energy in the bulb. Energy measured in joules, its measuring unit in joules, equivalent to volts times charge. Equal, we will remove the charges and using current times time. So joule equal volts times charges equal voltage times current times time. Joule equal volt times by coulomb or volts joules per coulomb. Okay? So again, potential difference, which is called by voltage. Energy carried by charges is consumed in components like resistance, lamp. We said before, all resistance, we can consider all devices working by electricity as a resistance. Bulb, TV, radio, charger, heater, all of them called by resistance, fan. Okay? So, energy carried by charges is consumed in the components like resistance lamp or heater of the circuit. When the charge flow through the lamps in the circuit, their energy is converted into form such as heat and light energy and sound energy and more. The energy converted per unit charge passing through component is called by potential difference across the component. So the potential difference across the component in the circuit is given by the work done in the component divided by charges passed through the component. Potential difference equal E divided by Q. The unit of potential difference is volt. Okay. This is voltmeter. It is the device which used to determine the value of potential difference. Now we will talking about Ohm's law. Ohm's law studying the relation between potential difference between 2 points and electric current intensity passing between these 2 points. Okay, so again, Ohm's law studying the relation between potential difference and electric current. Okay, state the relation between current, voltage, and resistance. German physicist George Ohms had the law named after him because of his extensive research. Voltage is equal to the current multiplied by resistance. Okay? So, Ohm's law states that the electric current intensity passing between 2 points is directly proportional to the potential difference applied between these 2 points at constant temperature. Okay? At constant temperature, this is condition. The temperature must be constant. So, if the potential difference increased between 2 points, the electric current intensity passing between these 2 points also increased. Okay? The mathematical relation of Ohm's law, V potential difference equal I electric current intensity multiplied by resistance. Resistance measured in ohms, its measuring unit ohms. Okay, current measured in amperes, V measured in volts. Okay, it is the mathematical relation of Ohm's law, V equal IR or I equal V divided by resistance. V equal electromotive force or potential difference, I current or resistance, unit V divided by ampere. Okay, right. So what is meant by resistance? It's a new value or new definition in this lesson. Resistance, it is the opposition that push from the voltage. Resistance affects the speed of the current. And we can define it by, it is the opposition that faces electric current during its passing through a conductor. It is the opposition that faces electric current during its passing through a conductor. Okay, the symbol of resistance called by R. I said before, resistance means any device that can be worked by electric energy. Okay, and give you many examples like TV, radio, heater, charger, fan, all of them called by resistance. Okay, unit or measuring unit of resistance called by ohm, and its symbol of ohm. Okay, copper connecting wire is a good conductor. It offers a little resistance to the electrons and the current passes through it easily. So we using copper in electric conductions. Nichrome is not such a good conductor. It has bigger resistance to the electrons and less current will flow. Okay, so we try to using material has little resistance in the electric circuit. So we prefer using copper in the connecting of electric circuit. Okay, resistance. How much current can a cell push through resistance? This depends on the resistance of the resistor. The greater its resistance, the smaller the current that will flow through it. The resistance of component is measured in ohm and is defined by this equation. R equal V divided by I. R, which called by resistance, equal potential difference divided by electric current. This is the symbol of resistance. Okay. We have two types of resistor. The first one called by fixed resistance and its symbol. Fixed resistance means the value of resistance doesn't change as time passes. Okay? Fixed resistance means the value of resistance of this device doesn't change as time passes, or we can't increase or decrease its value. Okay? Fixed resistance, we can't increase or decrease its value. Second type of resistance called by rheostat. And we can call it by variable rheostat. Variable rheostat. Okay. Its symbol in the circuit, arrow and resistance. Okay. Rheostat, its importance in experiments to control the electric current intensity. Okay. This means that if we increase the value of resistance or decrease the value of resistance, we can change the value of electric current. From this equation, we observe that the relation between electric resistance and the electric current intensity is inversely proportional. Okay, so if we increase the value of rheostat, we will decrease the value of electric current passes through the circuit. Okay, so the importance of rheostat is to control the value of electric current intensity inside the circuit. Okay, let's complete. Okay. Now we will talking about the voltage and current. If the voltage in the circuit increase, the current will increase. This is from Ohm's law equation. Ohm's law statement, okay, said that the electric current intensity between 2 points is directly proportional to the voltage. Okay, this means that the voltage increase, the current increase. Okay, and if the voltage decrease, the current will decrease, and we call it by direct proportional relationship. Okay, so what is the relation between resistance and the current? If the resistance and the circuit increase, the current will decrease. If the resistance of the circuit decrease, the current will increase. Okay, we called it by inversely proportional. From this equation, I equal potential difference divided by resistance, we can say that there is only two factors affecting on the electric current intensity. Number one called by potential difference, and its relation is directly. Means that by increasing the potential difference, the electric current intensity increase. By decreasing the value of potential difference, the electric current intensity decrease. Okay, so the relation between them directly. Factor number two is resistance. Relation between resistance and current intensity is inversely. Means that by increasing the resistance, the value of electric current intensity decrease. Okay, by decreasing the value of resistance, the electric current intensity decrease. Okay, so the relation between them inversely proportional. Okay, problem. Our speaker used 200 milliampere of current at maximum value. The voltage is the current is used to produce a magnet which is used to move speaker 12 volt. Find the resistance. Okay, so the resistance, Ohm's law says that resistance equal V divided by I. Don't forget to convert I from milliampere into ampere. Okay, so we will divide 12 volt by 200 times 10 power negative 3 to convert from milli to ampere. We must multiply by 10 power negative 3. Okay, it will be 12 divided by 0.2. Okay, So the answer will be 60 ohm. So the resistance of this conductor is 60 ohm. Okay, thank you. We will do a new session talking about some advanced problems related to Ohm's law. Waiting us. Thank you very much.